So yeah, my name is Yen, obviously, and I will talk about NetFlow, more specifically the security uses of NetFlow in a backbone perspective. I mean, more specifically, to look at the infrastructure part. So I'm not really interested, well, the point is not to have a look at peer-to-peer or massive events in the data plane, but more events targeting the control and management plane, but whatever. So there is mostly two parts. Yeah, mostly two parts. The first part being what's on the exporter side of the thing. So how one configures NetFlow on its routers or things like that. And the second part is on the collecting side. So what to do with the exported data and what tools are available and some overview of what we can do with said tools. And then short conclusion as usual. I have, so this is a part with slides actually. I have a live capture of the NANOG traffic on my locally on my disk. So rather than to present screenshots, I will just have a look using some tool in the traffic which was captured in the first few previous hours. That's it. So to begin with the basics, what's NetFlow? So everybody knows what NetFlow is, but okay, just this is a way for the routers to export some information regarding the packet forwarded. Yeah, so basically NetFlow is two things, well, several things. A metering process on the routers and routing devices, and a protocol on the wire to export and work on this data. Yeah, so for different uses like real-time or near real-time, because flows are not exported really real-time, we'll see that. And then for more long-term trending or whatever you want to do with them, and forensics, that kind of stuff. So at first, NetFlow was and is pushed mainly by one prominent vendor in the router land, but this is now an industry standard, meaning that it's in the process of being. Well, there is an IETF work group, IPFX, working on normalization stuff, and an important number of other vendors beside vendor C support NetFlow. So this is quite an industry standard. The other standard or aiming to be a standard would be S-Flow, but without the same support, device support. So okay, so yeah, other technologies, crane, diameter, and S-Flow. At one point, yeah, so when the IPFX workgroup started to work on flow-like export normalization, they considered different possibilities to use as a base for the new protocol. And so they choose NetFlow v9. So I will talk about the different flavors of NetFlow. But just to say that there were different proposals from different vendors, like SFlow, as I said. And then NetFlow, Cisco NetFlow, was chosen as the base for IPFX. So what's a flow quickly? So two definitions, first one being, well, loose one, but it works. So basically, you have packets forwarded on your routers, and yeah, some of those packets share some characteristics, and okay, you decide that this set of characteristics define a flow. Okay, same definition, more verbose. And so, well, actually, on the wire, what's a flow exactly? So some key fields, a number of them, and some additional fields. I am talking here about the version 5 of NetFlow because I won't enter into big details, but there is different versions of NetFlow historically, and so currently we are talking mostly about NetFlow v5, which is basically the standard, but NetFlow v9 is pushing. So okay, so a flow version 5 is the key fields like source and destination addresses, source and destination port, the layer 3 protocol information, type of service, and the input IF index, and then some additional fields like byte count, packet count, the start and end time of the flow, the TCP flags when available or when relevant, of course, and some routing informations like next hop, source and destination AS when available. So a few characteristics based upon that is that a flow really is about layer 3 and 4 information. Flows are unidirectional, be it ingress or more recently egress, but I mean that if we take, I will say a bit more later on that, but well, when we want to look at traffic, what we have in mind is layer 7. Well, when we want to do some analysis, what we see is layer 7 traffic on the wire, but the flow records which are exported basically split the two ways of the layer 7 communications or stream or conversation. Call that whatever you want, and so you end up with two records in both ways, if I'm clear. And okay, some other characteristics, but yeah, that's not without cost for the router, like memory, CPU. So things you have to take into account before enabling NetFlow export on some of your boxes. And yeah, okay, not the perfect solution, blah, blah. So rational, NetFlow was first appeared, if I'm not mistaken, on 96. So I'm not a Cisco guy, so check with your rep, but I think that's the point. Okay, so old techno, the truth is actually that a lot is happening in the protocol and implementation front. So, and there is a lot of projects and jumping on the NetFlow bandwagon. So, yeah, a lot of things are evolving around. Okay, and even with NetFlow being an old techno, I mean, I keep seeing in the forums and the SP forum yeah, I want to monitor that kind of layer 3, layer 4 information for some customer's link or on some part of my backbone. How should I do that? Or what tool do you use to, or what can I do with NetFlow? I've heard about NetFlow. I don't know what the uses are or whatever. So, okay, even being an old and well-known techno, I think that there is room for, well, I hope so, for a tutorial from the beginning, from the router side to the tools, actually. And yeah, other point to keep in mind is that infrastructure is, well, still is a potential target, one way or another. Everybody, yeah, you know that, but there have been several recent Cisco advisories, very recently, a few weeks ago. So, I mean, stuff is happening in the infrastructure. When I talk about infrastructure, like everybody else, but I talk about, yeah, obviously layer 3 and above stuff, because, but so routers and infrastructure servers like DNS. And so, yeah, okay, infrastructure may be a potential target. But what's needed actually is actual insight. I mean, there is a lot of phantasms and third discourses being heard, and what we need, what you need on your backbones, on your network, is to know what's happening. Is there actually packets, attacks targeting your routers? Is there even low key profile, low profile attacks? I mean, just dictionary attacks against telnet or SSH port or against some of your IP space used by your infrastructure or stuff like that. That's important to know, by the way. Well, that's my point. So NetFlow versions. I talked about NetFlow version 5 and version 9. So there is a different version of the protocol. The thing is that actually, yeah, I said that we are talking about two things: that a protocol on the wire and a process on the metering side to gather information prior to export. So this is really two different things, and so in both sides, things continue to being worked on, like with the IPFX working group, and Cisco, sorry, on its own keeps on improving, well, or complexifying sometimes the stuff. Okay, and anyway, so regarding flavors or versions or stuff like that, it depends a lot of some combinations of software, hardware, and the vendor that you have, and yeah, combinations of those. Meaning that, okay, some vendor, some non-C vendor, for example, will support obviously only version 5, for example, and only a subset of it, meaning that some fields which are part of the protocol will not be exported or filled if you enable NetFlow export or on some device. And yeah, if you, for example, Juniper supports NetFlow too, and so NetFlow version 5 only for now, and there is some particularisms to when you enable NetFlow. So depending on your hardware and software and vendor, as I said, there is many things to keep in mind and many particularities just waiting to bite you one way or another. So there is no universal recipe to enable NetFlow. Just yeah, it depends a lot of the context, but anyway. Yeah, so, sorry, I'm waiting. So, back to the versions, as I said, version 5, de facto standard. Well, less and less, by the way, because, for example, I said that I collected some traffic on the NANOG, network, so from the border router, so some hours ago, and by default, the version exported was version 9. So things are changing anyway. So we saw what's a flow, how a flow looks like version 5. On the version 9 front, many things have changed, by the way. So first of all, this is template based. What it means that it brings a lot of flexibility. Well, for now, the only flexibility that you will get with NetFlow v9 is that you, as a user, has to be very flexible because your routers won't be any more flexible than usual, meaning that you don't have the choice of the templates for now. This is changing. I don't want to have somebody from Cisco raise and say, okay, no, this is changing, but for now, flexibility means you have to be very flexible. And so, v9 brings some interesting features anyway, like other transport beside UDP, like IPv6 support. Well, this is another discussion. Some, more importantly perhaps, some layer 2 fields like make addresses, and some additional layer 3 fields like TTL, IPID, and BGP next hop information. Probably not processed by your collector of choice. What I mean is that an important number, more and more collectors support NetFlow v9, but for example, for the collector I will talk about later, they support the templates and the v9 protocol, but they don't grok the additional fields yet. So meaning that you could well enable on your router, say, export of TTL, if it makes sense for you. For now, it won't be used on your collector of choice. Well, many chances are it will not be used. Anyway, so NetFlow v9 is a moving target, as I said, and some features are backport to version 5, like transport independency. So recently, NetFlow export on Cisco routers gain, transport independency, meaning that you can enable TCP, HTTP for the export. And then there is NetFlow version 10, which is also known as IPFX, so which is a IETF beast in this front. It's based on a fork of NetFlow v9, because I said that NetFlow v9 was chosen as a base for the standardization effort. So meaning that NetFlow v9, which is what's supported by your routers right now, well, depending on the iOS version and some configurations like that. But so this is not the same as what's working on under the name IPFX. So, and there is other versions like version 1, which is the first, and some versions which are used only, which are relevant only for switches, like version 7, version 8 brings some router-based aggregation. But anyway, now even the switches, so layer 2, layer 3 BIS support version 5 too. So normally you should have on your collectors, you should collect only version 5 and perhaps version 9. That's the point. So particularisms, I said, support is not the same on all devices. For example, not all boxes from said or sub vendor supports NetFlow. So if this is a feature which is important for you, take that into account. And even when supported, I mean, for example, on some layer 3 switches, TCP flags are not exported. So, well, not a big deal, but yeah, there is a lot of particularisms, okay. Yeah, and on routers too, you have some particularisms. So when you want to enable NetFlow on the 12Ks, you have that big caution, big warning on every doc and every public documentation that saying that, okay, all kind of trouble may, well, just do that during the appropriate time frame. And then there is another caution, which is less advertised, saying that the way it's done on older engines for the 12Ks, enabling full NetFlow export puts quite a burden on the memory. And so, and for the funny, I'm not sure, but for the anecdote, the cautions are two, so don't do that. I tried on the 12K, and so you have two 12Ks, and on one you configure the NetFlow export, and you lose connectivity with your box, and so you check on the console, and you see funny messages like usual dsafe and distributed safe disabled due to low memory conditions, and so you say, oops. And so, but all your BGP peers went to the other 12K, and so the other 12K, which is short on memory, to start to, okay, but not a good idea, by the way. So do test on a lab, not in production. So yeah, this was some overview of what's NetFlow. And then on the flow cache, so the principle of NetFlow is that basically you have one or several, depending of what we are talking about. So you have a memory cache which is kept on the routers, which is enabled not for, well, the wording is a bit confusing. It's enabled, yeah, you enable NetFlow export and NetFlow capture per interface, but the cache is global for all interfaces, yeah. Okay, and so you can tune the number of entries you will keep anyway. And so the point how it works is that for each packet entering an interface, so either you have a corresponding flow existing already, and so a number of fields will be updated, like, for example, yeah, obviously the bytes and packet counts will be summed. The end time will be updated with the new end time of the new packet arrived. And so TCP flags, of course, we are talking about TCP flags. And by the way, TCP flags are ORed together. So you have that field. And so if you have a new packet entering with a TCP flag which was not seen before, it will be ORed with the other one. Or if not, if there is no already an existing flow matching the packet, a new entry is created. and then you have an expiration mechanism to manage to keep the cache low, and then some export if configured. But by the way, you can configure NetFlow without configuring the export. This is two unrelated things, even if it makes less sense anyway. And so expiration mechanism, I said, so basically this is either we are talking about a TCP packet, and so easy that when you see a reset or fin packet, you expire and export your flow, or after a timeout for inactive flows, meaning flows during the time there have been no new packets entering the cache, or after a timeout for active flows, meaning that if you take a long TCP session or whatever session, like SSH or tunnel or whatever, it will be splitted into timed record, and so you will have to reconstruct your record, meaning that a long SSH session will be splitted upon many different flows, many different records actually. And so, yeah, when the cache is full, it will be expired too. Yeah, sorry, I'm waiting for the laptop to. Okay, so the basic example to export to configure the flow cache on a router is something like that. So, yeah, first on the global configuration, where you say that you want the flow cache, you say the version, and if you have a BGP peering, BGP process on the router, you decide, you say if you want the origin AS or peer AS, okay, self-evident, and then per interface, you configure the actual flow collection mechanism. So ingress or egress, by default, well, this is ingress. But the discussion actually depends a lot of what the kind of device we are talking about. For example, if you want to capture traffic, multicast traffic, depending, it may be interesting to enable egress export, egress collect rather than ingress. So it depends of your requirements. But basically, the simple case is that you take every of your interfaces and you enable ingress, collect, and so, yeah, with that you are able to match every packet back and forth, every traffic back and forth forwarded by the router. Okay, and with version 9 specifics, so you can add, as I say, but you can add capture like layer 2 or the TTL, the VLAN ID, and yeah, some V9 specifics, as I said. And then this is a part on the layer 2-3 switches, so ND, NetFlow data export, and so you have yet other particularism. So just to export, to collect the flows. So depending, and the point to keep in mind is that there is a flow mask on those devices, and so by default you don't capture all the full granularity of information, but you will restrict to only the addresses without the ports, or so if you want full granularity, you have to say that. So from a security perspective, this is good. The more granularity we have, the better, of course. Now, from an operational perspective, this is not the same. So it depends a lot of your box and OS are overloaded or not. And so other vendor, other practices. So on Juniper, NetFlow relies on adaptive service interfaces, or whatever their name is. And basically, the way to enable NetFlow is to, so you define sampling rule in the firewall statement, and where you can put a sampling. Obviously, sampling can be 1, so 1 out of 1, meaning no sampling. And then you define input filter, which are called for every interfaces where you want to enable NetFlow collect. And so, yeah, I have an example. I mangled a bit the Juniper configuration just to fit that on the screen, but the principle is there. And then just, well, one slide on FreeBSD. If you have on some parts of your backbone some FreeBSD routers, or perhaps not. Anyway, so there is a kernel netgraph for those being familiar with FreeBSD. So there is that kernel-based framework, which is called NetGraph, which is a cool framework, cool network framework. And so there is, with many different nodes to enable very interesting features. Anyway, and so there is the NetFlow NetGraph node. So, and you can use that with a NetGraph node for the FreeBSD native packet filtering IPFW. And so you end up with something like that. So that's very convenient. I have another example, but that's dead easy to define filters. I mean, so if you want to enable the capture of only a subset of the traffic or something like that. So, okay, the syntax is, okay, what it is, never mind. That's quite simple. But if you just want to enable, I don't know why, traffic for SSH, for example. So this is only a matter of crafting ACL in the filter, in the packet filter of the FreeBSD box. So the syntax is that simple. And so, yeah, the bad news is AS fields are not populated, even if you have a BGP speaking daemon on your FreeBSD. So if the purpose is to gather the AS fields and routing information, don't use FreeBSD. The other bad news that I discovered is that it seems that ICMP, I have not digged in actually to see if this is just a problem on my side or I should push a bug report anyway. And so it seems that ICMP informations are not filled at all, meaning type and code. I will talk about that in some slides. But so, okay, no ICMP type and code if you use FreeBSD with NetFlow. Yeah. So I talked about the flow cache and how data are expired upon certain circumstances. And so you have a way, as I mean, to keep the cache under control. I mean, so you can tune its size, obviously. So the default size of the cache, of the flow cache, depends a lot of your hardware and its memory. You can play with the edging of entries, meaning that you can, and that's a good idea to lower the export, the active timeouts, and because so as I said, or perhaps not, but it was written in a slide. But the default active timeout for a flow for a record in the memory cache is 30 minutes, and meaning that if you want to do near real-time analysis with your records, a long flow, you will not collect it, at least before, after, yeah, okay, you see there is, so it will be at least 30 minutes during which you will not be able to see some records of interest. So just you can lower those edging timeouts. You can enable, and probably depending on the size and the traffic considered, you will need to enable sampling. So, okay, I will talk about sampling a bit later. You can do input filtering if you know that you don't need to look at that kind of traffic, or you need to only collect that and that part of the traffic. You can put filters which are defined like policy maps on Cisco. So to say, okay, I'm only interested by the traffic matching those layer 3, layer 4 kind of information. And then I talked about flow mask before, which is the way on the catalyst to lose some granularity, but okay, and to manage more traffic if needed. I don't know what my laptop is doing during this time, but okay. Anyway, some performance considerations. So each entry, each flow record in the memory cache has a size which is 64 bytes. So, okay. I talked about the version 8 of NetFlow, which brings aggregation router side, so meaning that when you have a router supporting version 8 and that you enable aggregation, you will end up creating another cache in which data are aggregated, for example, by NetMask or by a number of fields where you can play with. But by the way, aggregation is collector friendly because of course you decreases a lot the traffic exported, the record exported, but this is more costly CPU wise. So the point being that the less the router is doing beside routing, the better. And so that's the job of the collecting process to do the CPU intensive task, not the router. For some platforms, this is done in hardware, basically, only except for the export by itself. So it's not that CPU unfriendly. And okay, so before enabling that, just you plan, you test, and as usual, I mean. Sampling or not. So this may not be a choice. Well, the decision to sample or not, because depending on your traffic, okay, you may need to sample. So we are talking about different kind of sampling, by the way. There is flow sampling versus packet versus time sampling, and deterministic versus random. So, for example, packet sampling is to sample one packet out of 100, and okay, and if this is time sampling, so you sample every 10 seconds, for example, and okay, if you have randomness, this is great because with deterministic sampling, you may lose some burst. You may not see some burst in the traffic because you sample at every regular interval, I mean. So anyway, so the choice is not yours, meaning that the type of sampling that's available on your box does not, that's not your choice. It depends on your box, okay, and the iOS version considered, and whatever. So you may need to enable sampling. Of course, we are talking about security. So as I said already, but the more granularity that you get, the better. But again, this may not be possible. So trade-off as usual. And so if we want to look at the cache flow in real time, so we are not talking about exporting for now. We are talking about connecting on a router and just have a look at the traffic. And even without exporting and collecting the records, when something is going wrong, this is interesting to have this feature. I mean, so okay. And so beside, so this is the main. This is a way to query the main flow cache. And there is also a top talkers cache. So in recent iOS releases, it was in the T-train. I'm not sure it has been pushed into the main releases. Anyway, so I mentioned that because this is not interesting, but so the purpose is to create some dedicated cache where the router keeps the top talkers of the networks. So the point is that you have to enable that second flow cache, and during configuration time you have to define the number of entries you want to keep into that cache and the sort criteria. So okay. And an example, so self-evident. And there is another feature which is called, the dynamic top talkers, where you should check with your iOS versions again, and where in that case, dynamic top talkers, you can really query. So we are talking about your main cache flow, and so you can query dynamically that cache flow, and so define in a dynamic fashion the sort criteria, for example, and so you can restrict the output matching only a subset of the fields, and yeah. Yeah, so in the Juniper case, there is this, I don't want to do any, I like every vendor a lot, but there is this cool CLI, I mean, where you can use pipe statement and to just match a subset of the output and just trim the output, and so that's quite powerful. So okay. And my examples would not be complete without FreeBSD. So you have that flowctl CLI just to query your cache. And of course, you have the usual grep, sort, cut, whatever Unix tools. Export, so we saw how to enable, the metering, the NetFlow metering process on the routers, and the flow cache, and how to look at the cache. And so our goal here is to export the data, actually, not to keep that on the routers. So the way it works is that when upon expiration, so we saw the expiration mechanism on the cache, upon expiration, flows are exported if export is configured, and so they are all packed together, okay, and they are sent on the wire on a UDP datagram. So there is a NetFlow header with a version, with a sequence number, with the number of records which are exported, and then you have those records which are packed together on one datagram, so between 1 and 30 flow records per export. Okay, you can do loss detection because you have a sequence number, but yeah, there is no provision for retransmission. Obviously, yeah, we are talking about UDP, but at the application, at the protocol level, at the application level, there is no retransmission either. So, I mean, you can detect that you have some loss, but nothing more. Yeah, sorry. So the way to export, to configure the export on a Cisco router is, okay, so IP flow export, you give the destination address and a port, and now a protocol, like I said, like UDP or SCTP, and a source, so the loopback may be a good idea. Always the example on Juniper, so okay, syntax is what it is, but okay, this is pretty self-evident. And then on FreeBSD, of course, again. Others. So just for the sake of it, because you don't need that, but there is other software-based NetFlow metering processes, exporters, if needed. Sometimes, yeah, okay, we never know. So mostly they are based, well, there is two families, but mostly they are based on PCAP. So you have some PCAP process and capturing the traffic real time and recreating NetFlow records and for export on the wire using the usual NetFlow protocol, I mean. So you have a number of projects existing. Okay, and you can have other sources like firewall logs. So there is one solution for NetFilter. There is one tool for PF, packet filter logs. So just you have a process passing the logs of your firewall and crafting NetFlow records following that. The idea here is that it may be useful, well, that kind of tools may be useful more in a forensics way, for example, so you have some packet capture or whatever, and you want to use regular NetFlow tools on that for a number of reasons. And okay, this is a way to do that. Exporting, so you may want to improve reliability of export. The first things that you may do is to configure multiple destinations. Well, at most 2, but you can do that. So yeah, on your routers, depending on the hardware vendor, on your routers, you can configure at most 2 destinations. You can export to a multicast address, to a multicast aware collector, and so that's pretty convenient because out of the box you are provided with redundancy if needed, scalability, and collector diversity, meaning that from my own experience, there is not one collector solving all problems. So you end up with several different tools to work on the same set of data, basically. And so a solution like multicast makes it easy to just stack up new collectors or to test another brand or another commercial tool. You just stack up on the pool, and okay. To improve reliability, other ways to consider using other transports like SCTP. So as it seems, I've not followed recently, but SCTP is a must. SCTP support is a must in the IPFX draft, actually. So So, but when I tested that recently, so Cisco routers can export over HTTP no problem, and quite some months, some weeks, some months ago, HTTP support was committed to in the FreeBSD3, and so my first point was to say, okay, just let's do some tests. And the problem was to find a collector supporting HTTP actually. So I ended up testing that with NTOP, which is not really a collector either. But anyway, NTOP supports HTTP too. So okay. Some considerations which are important to keep in mind. So I talked about the unidirectionality, so of the records exported, and also of the traffic exported. So meaning that routers, the information exported is from your routers to some collector, probably more in the inside part of the network. So, okay, so this is UDP based. There is no crypto checksum whatsoever. So, well, so no authentication of the exporter in any fashion, and you export 48 bytes long record for every packet, meaning in the event of denial of service, where you can have a lot of small packets, you will end up exporting 48 bytes long records. So that's another denial of service, I mean. So, okay. Anyway, you may want, that may be wise to protect the link between exporter and collector. If not, we can imagine an attacker crafting rogue NetFlow records and to bury completely your legitimate collection under rogue records or other things like that. So yeah, ICLs or URPF to check for anti-spoofing, TCP wrappers mechanism or alike are of use actually. So it was for the router side of the things. Okay, and now we'll go to the collect side. What should do a collector on my mind? Well, we are talking about, first we are talking about different things. Because under the name collector, you will find very different tools with very different purposes, of course. And so from my own perspective, I'm talking about keeping a per record granularity, because the purpose is to be able to do forensics or to do analysis at some point in time, back in time, as long as your storage capacity afford you. And so per record granularity, aggregation facilities, because when you end up with a lot of records, you need to do aggregation on the data and to have other views to be able to spot things. Versatility, meaning that, well, some tools are very dedicated to a given task, meaning some tool will be dedicated for DOS detection. Some other will be dedicated for performance monitoring or a lot of different uses like that. And as an analyst, you never know what kind of what things you will want to look on the traffic you are after. Meaning, so versatility is important because you are not constrained into a given schema of digging into things. A powerful CLI is important, and graphs. are rather important, because no matter what the CLI is, when you have some amount of data, the only way to make sense of that data is to have cool graphs, no matter what. So, and yeah, all of this can be splitted over different tools. So as I said, you may end up using different tools, even for the same set of data, even for the same job, I mean, security perspective only, and just using two different tools, for example, previous job, I was working for a satellite operator in Europe. And so we use two different tools, one commercial one from a vendor in Michigan, and one open source one, which I will name because I will talk about that open source one, which is NFDump and NFSen. And so the only fact to have two different tools, well, this is rather convenient to look at the same problem with two different set of tools and two different ways to present the information. And some problems are difficult to spot with one and easier with the other, or the reverse. You see the idea. So nothing prevents you. Well, after that, it depends on your capacity storage again, and your time, and your teams, and a number of different things. But this is not technical anymore. And so, as an analyst, well, what are your duties as an analyst? Well, easy that, basically, just relax with a coffee in front of pretty graphs. This is all that you have to do. Well, perhaps a bit more, but I mean, so you look at graphs, you check your top n's, whatever n and whatever meaning value we are talking about, and just build different filters to look at the traffic with different perspective, and to be able to spot some things which if not would go undetected by, okay. So the purpose is, yeah, to put filters and to say, okay, I'm interested in that subset of traffic, and so having a look at only traffic targeting infrastructure. So what's going on the control and management planes, more specifically? What are the look of my BGP session? For example, may I learn things by just looking at the flows of my BGP stations, or maybe not, I will give a screenshot. So what's the traffic directed specifically to my IP range used by the infrastructure on my network? What's the outgoing traffic from said addresses? That's important too, because yeah, okay, routers are hardly servers. I mean, so there is not a lot of outgoing traffic originating from their own management addresses. I mean, so that's important. That may be important to have a look at that. Some more consideration to keep in mind. I've said that already, but we are talking about some very, very IP-centric thing, NetFlow. This is somewhat changing with V9, with some layer 2 information, as I said, with better, with some MPLS support up to I don't remember the number, up to 3 or 4 labels. I'm not sure. But obviously, we are not talking about some any over whatever encapsulation scheme friendly monitoring tool, meaning that, okay, obviously you only have layer 3, layer 4, so all which is IP over IP or UDP over IP or layer 2 over whatever, you will have a hard time. So the best you can do, if we are talking about IPsec tunnels or whatever tunnels, if they are identified, I hope so, on your network, in your management. The best you can do is to capture the information just before the one endpoint tunnel, okay? Just so to have the full granularity and to capture the traffic just after the remote endpoint, so to have the decapsulated traffic again, okay. I said that TCP flags are blended or together. So for a full TCP session with the handshake and with data exchange, what we end up with is with two records in two different ways, I said, with all the flags basically set. So of course you have the SYN and the ACK, and you will find FIN or reset. And so there is no individual TCP flag granularity, except that, of course, you will find records on your records captured, collected, with only, for example, one or two flag sets. So this is an example with NFDump. I will talk about NFDump and how it works more in details in a few slides. But just the example, the logic is there. So I mean, the point, the purpose of the first query is to just look at all the traffic, or the records having only the SYN flag set. So the SYN and not any other flag, obviously. The second query is I want the records having the reset flag set, maybe along with the ACK flag set, but not other flag. So what you are looking for is a burst of SYN packets in one way and burst of reset packets in the other way around. So meaning it could be a large scan or some other event like that. So this is the best that you can do when it comes to TCP. You can do queries with every TCP flag combination, but I mean, if you have a full completed TCP session from the first SYN to the last FIN, yeah, you have no granularity. So, okay. And so I said that before, but layer 7 streams conversations, whatever the name, are splitted at least upon two different records. So as an analyst, that's not always convenient. I have a slide on that later on. And yes, the other orthogonal problem is that the source and destination, as we see it, as you see it, as we see it on our NetFlow records, does not match the sockets notion of client and server. And yeah, that's a pity. I mean that in certain cases, that's that easy to know which side initiated the traffic and on which side there is the server. But in many cases, there is no way or no easy way to decide that, except by applying more or less working heuristics on your traffic and say, okay, more on that later. But lost in collection, a very low key figure. I mean, but even on very small, very small setting with three pole line, 2 borders, we are talking about at least 7 gig of data per day collected. Christopher Moreau on the NSPsec BOF in some hour ago talked about that on their networks. They were talking about terabytes of data per day, something like that. So meaning that it's quickly a lot of data. even on a small ISP platform, you will end up quickly with tens of gig of data per day. Okay, so I'm talking about non-sampling here, but okay, this is a really huge, comfortable amounts of data to look at. With that said, what you can do besides prune all data, and so first midterm strategy is compression. You can compress your data. I'm talking here about flat file storage. Sorry. Yeah. So depending on the tool you use, they will store your data on some different kind of storages, like binary flat file, which is the most efficient, basically. It may be in a SQL database. It may be okay. So first thing, if you can, depending on your storage backend, you can compress older data for whatever meaning of older you may want to put. And long term, you have no other choice but to prune regularly old data and perhaps keep some aggregated views of the network. For example, only the top ends per month, for example. So the first 100 bandwidth eaters on your network every month or something like that, with different criteria for the tops. But okay. Flat file. Well, there is only this database temptation because it looks so cool. And I know that a great number of very clever people are storing that in a SQL database, but there is so much of an overhead over that. Anyway, so the most efficient storage is really binary flat files, but of course, having that in a SQL database enable of kind of interesting queries as well. So yeah, it's up to you. Other way to think about that is just store the raw, the bulk of your data on flat binary files, and send associated data in the database, like for example, matrices of traffic, or some resolution information of some sort, or some aggregated data one way or another, and so keep the raw meat into quick to retrieve format, and then use SQL database just by side to store related data and do the queries on the SQL and just retrieve. With what you retrieve on the SQL database, you are able to look further onto your binary. So the point is that, well, each tool uses its own format on disk, and there is no normalized on disk format. So it may be a pity or not, I don't know. There is not. Obviously, there is not. So the point is that if you end up using different tools for the job, you will hardly be able to just use a common store of data, but you will need to duplicate n time the data you want to look at, depending on the tools you use. So, so some popular collectors or tools to look at NetFlow and work on NetFlow data. There is just last word regarding this database issue. For what's worse, in the commercial front, in the commercial world, nearly all commercial vendors proposing solutions evolving around NetFlow, so more in a security perspective, but anyway, use a combination of the two, as I said. So the raw data on flat files on disk and some Postgres or MySQL installation beside to store associated data. Okay. Anyway, so there is a lot of different tools to work on with NetFlow data, both open source and commercial. Okay, with different strengths and weaknesses. So just some names: Arbor PeakFlow, which is I don't want to, but which is really a great tools. I've not tried LandCop. Cisco Mars. This is not, well, depending on what you want to do, but this may not be what you want to buy. Anyway, and so Q1 Labs has an offer to, and okay. And in the open source front, you have, the old and efficient and no matter what, flow tools. There is the older CFlowD from CADA. You will find Argus, Silk, and NFDump, NFSen. Okay, I have a lot more slides on NFDump, NFSen, and so others which are not really collectors, but tools which are working on NetFlow data or NetFlow-like information, like Egery, which is an interesting tool, by the way. Panoptis, which is a denial of service specialized kind of tool. NTOP, which, well, you all know NTOP, I'm sure, but so this is not a collector. My point, okay, NTOP is not bad. That's a pretty interesting tool. This is a memory hog, for sure. Last time I tried it, that was not a monument of stability, but it may be me only. And it does not collect. So I mean, it gives you an overview of the traffic exported, but you are not able to do forensics and to look actually at your records. So NTOP is out of scope. Stager is basically in the same category. That's a cool tool, but keeping only a very, very aggregated view of the data. So more to have trending and bandwidth and so on consummation, and so not what we are looking after. So flow tools, my take on that. There is a lot of projects, in-house projects using flow tools. So if you use that, that's perfect. That's a very, very good tool. I'm not trying to say bad things or whatever. So this is a historical collection and analysis package, because all those tools are doing both the collecting process of the things, and they have the client front ends to let you dig into the data collected. There is many pages and associated scripts and floating around and contributions and many things. There is a huge user community. I have no figures, but okay. Well, the CLI is in my, well, okay, I'm not that fond of the CLI of flow tools, but that's only me probably. And with flow tools, you will find a number, of graphs with. So you have FlowScan, you have CU Flow, and others like that. So the great thing is that you are not tied with some graphical front end. You have flow tools on one side, and you have different possibilities as a graphical front end. On the minus side is that, okay, they are not tightly coupled together. So of course, that's not exactly maintained. That's not necessarily a problem. I mean, because, okay, if it works, no need to be maintained, of course. For example, there is no version 9 support. So version 9 has brings all kinds of complexity and maybe quirks with it. But as I said, the NetFlow, the record collected a few hours ago by default were exported using version 9. So the router could have been configured with version 5, no matter what, but not supporting version 9. Maybe more and more of a problem in the future. Okay, anyway. Other versatile, in the versatile category, other tool, which is an FDump and FSEN. Well, this is two sets of tools, and FSEN being the CLI and collecting and CLI part, and FSEN being the graphical front end. So I will talk about this one for different reasons, but the design is said to be clean and modular, so you know what that means. The CLI is very, very powerful and at the same time simple. I mean, the filters are in the pickup-like fashion, so to just query a subset of your traffic, you use the syntax you are accustomed to with TCP dump and the like, so that's very convenient. The good point is that there is an FSEN as a graph front end, so they are tightly coupled together, so it brings all kinds of interesting possibilities. It takes input from NetFlow v5, v7, and v9 transparently. But in the v9 case, not all fields are supported. As I said, if you configure on your router export of, say, TTL field, an FDump will not be able to, well, it will take the traffic on the wire quite fine, but it will not store that field. Yeah, and it takes input from SFlow if needed, so that's pretty cool actually. It's actively maintained by a very cool guy, Peter Ag from the switch.ch. And Peter is really responsive. I mean, if you have some suggestion, some bug report, some whatever, some ID that you want to be pushed, you are more than welcome. There is a mailing list, and so you can contribute. And okay, for example, some days ago I reported privately because we were on, okay, whatever, a bug regarding ICMP decoding, and I had a patch in the 2 following hours. I mean, so really responsive. There is a plugin system. So that's great. So that's an easy way to build more capability out of an FDump and FSEN. Maybe the problem is that there is not a lot of plugins available. So some people are using in-house plugins privately, but there is no common repository of plugins. And so, okay. There is some patches to, like, okay, NF split or Twinter or patches or external contributions. More on that later. There is a steadily growing community, by the way. So on the very, very good points, versatile, so you can use an FDump for network troubleshooting, all kinds of troubleshooting, performance considerations, security, whatever, be it for real-time data or long-term trending and or forensics or so, yeah. And it comes too with flow tools to an FDump converter. So Peter had very, very nice move. So yeah, and so the winner is obviously. So an FDump and FSEN with some more details on the architecture front. You have 2 processes, NFCAPD and SFCAPD, sorry, which are responsible of collecting the data coming from the network. So NetFlow for one and SFlow for the other. Those daemons do absolutely no pre-post processing of the record. So the data is read from the network and written to the disk in fixed size binary files. So 5 minutes. And they made demugs to other collector. If you want to use another brand or another type of collector besides, yeah, you can just configure an fcapd to replicate all the traffic received to another address. And so you have an fdump on the client side to read the data stored and work on that. And you have some other, like an freplay to replace the traffic expire, and fprofile to manage profiles, and yeah. Okay, and you have an fsen, which graphs the information based on RRD tools, and which act as a front end to NFDump queries with a plugin management system. Installation is rather simple, actually. So you can download the tables on SourceForge. You have two branches, basically, the stable branch and snapshots. Currently, there are snapshots for the upcoming 1.3 NFSen release. It brings really major usability improvements. Okay, but there is some not stability problem. Peter, if you hear me, but this is really a work in progress. So you may see a new snapshot every 2 days or so, fixing the problem of the previous snapshot and bringing perhaps some more problems. So you are, okay, you know. Anyway, there is an upgrade path provided between releases, snapshots, whatever. So you are not supposed to lose data when you upgrade from one to another version. To install compile NFDump, all you need is basically a C compiler. And as for NFSen, what you need is Perl, PHP, RRD tools. And so, okay, PHP extension like session and socket. You may need to bump the maximum number of System 5 IPC semaphores because it consumes one per source, per collector. So, okay. NFDump, so principle is simple. It treats NF-capped stored files, and you can use pcap-like filters, as I said, and okay, and you can do all kind of interesting aggregation, post-processing. So, for example, aggregation per subnet if you want to have a look at the traffic, but you want to aggregate on /24 or whatever. And you can produce the top ends consumer of by flow or packets or bytes or whatever, and order the results. Okay, and then display. So, and display, sorry, you have some predefined formats for the output, and you have also user-defined. So an example, it supports the format style of formatting, sorry. So predefined formats where you can say that you want the classic output and long extended to have more data like the TCP flags, if any. Pipe is actually the more scriptable output where all fields are separated by pipes, and row where you can have all the fields done. Okay, and you can define your own filters format if needed. If you want to display only the duration and source and destination address and port, so something like that works. Another example of define output to display AS matrix traffic. So okay. If you really need to, you can define your own formats And so in nfdump.c, the author actually explains how to define that. So that's quite easy, actually, if you need some really user-defined output of your own for whatever post-processing that you may need. You can do that, and you have to, so you read the instructions in nfdump.c and recompile, and that's it, basically. And so it was for the nfdump part. And for nfsen, you have a rather explicit configuration file where you will put forth various passes, like where are installed the binaries, where are installed the front end, the data repository, whatever. And okay, and some watermarking, this watermarking, and stuff like that. And this is how it looks. I go really quickly on the screenshots because I have live screenshots, as I said, so much better. And data organization, you can organize on this the data with different schemes, so depending on your configuration file. So you can decide to have all the data collected, in one big directory, but it will fill up pretty quickly with 5 minutes slot files, or you can have different hierarchies depending on your needs. And data organization, well, profiles, we'll see that later, managing profiles. You can manage, so profiles, we'll see what profiles are, but you can manage profiles using the CLI or with a web interface, actually. And so just an example of building a profile to look more in details of UDP traffic on some given port. This is how it works. And channels, but we'll see that detail. Okay, I will switch. So actually, this is the traffic captured, captured. The NetFlow, the NetFlow records as exported on the border router of NANOG from yesterday afternoon till right after I started to talk here, right? So this is the main tab panel. Okay. And so in the graph tab, you are able to have a look at the different, at the traffic using different metrics with number of flows and packets and bytes, I mean. And then you have a detail tab where you can do actually queries. So I mean, if you want to work on some, I don't know, and just do okay. So you see the ID, basically. So you have your graphs with the traffic, and you are able to, define some time window and build queries to look actually at the traffic which was collected. And the nice thing is that you are able to define your filters and profiles to look at the traffic with graphs. So an example, I built a few filters to look more in details at the traffic, and so defining some common uses of some pattern, some network pattern, like tunnels, web, well, slammer, Windows traffic, Windows verbosity, mail. So actually, to do that, yeah, I define a profile called main, and yeah, in that profile you define channels on it. Each channel being given a filter of traffic. So channels are, I don't know, perhaps some of you had some previous experience with with a stable branch of NFCN, but I can promise that there is the channel stuff is completely new and is rather powerful. Before that, you were stuck basically with one filter per profile. Okay, I go quickly. Thanks. And with non-nestable, stackable profiles. So okay, so quickly. So you see, you define a profile, so rather simple actually, and you define channels with a filter information associated to each. So, well, the way I did that was to put in mail all traffic for SMTP, IMAP, and POP, and then, okay, you see. So, for example, in tunnels, I put HTTPS, but okay, it could be HTTP. It could be web surfing as well. So that's another. Quickly, and just I did another filter profile. Sorry, where okay, my point was more to look at traffic between the different subnets. So basically, there is 3 group of IP address considered. Well, 4 if you want. There is traffic from the big evil internet, between the big evil internet and the dynamic pool of addresses used by your laptops, DHCP leases, I mean. And there's traffic from the internet to the pool of addresses used by the routers and the infrastructure in the network. And yeah, okay, basically that's it. And then traffic between the dynamic pool and that infrastructure, and ghost traffic being in small red. Let me see. Ghost traffic being traffic directed to not attributed IPs in the infrastructure space. So the nice thing is that you can unselect channels to see more in details some traffic pattern. Okay, and so if we just have a look quickly. Sorry, okay, so that's some output. Obviously, we need to dig further into to see what kind of traffic to non-used addresses were captured. This traffic is actually pretty interesting. Well, perhaps not this one, but in general, because a nice way to have a trending on what's happening, the temperature at large of the internet, and some macro events or micro events for geographically close to you, is to look at traffic where nobody is listening in your infrastructure. And you can see a lot of different patterns and trendings and stuff like that. So, and just last thing for a plugin I talked about, or perhaps not, Port Tracker, which is the only plugin so far existing for NFCN. And so, okay, the name is rather self-evident, the port being to track the top talkers ports, but you may end up, okay, my base is plain wrong here because there is only dynamic ports, but as I am not capturing traffic anymore, it keeps updating with, okay, anyway. And just, okay, resolution, okay, I have a screenshot for that. Now you have resolution, and that's great, that's new too. And you can configure, so you have name and AS resolution in NFSen. So you can configure that if you look into lookup.pm in the libexec directory. If you want to use another server for AS resolution, or change the timeout. For example, the timeout 10 seconds is rather low, and so you may need to increase that. Okay, plugins. I said about plugins. There is patches floating around to enable old winter style RRD tools to look further into the traffic captured with NFSen. And there was some discussions. To know if that ought to be integrated into the main trunk or not. So I don't know what will follow, but anyway, so Old Winter is an algorithm used mainly in climate changes, right, to spot anomalies in traffic. And so the nice thing with that patch is that you can, install that in parallel with an existing NFSen installation. So you are not supposed to break your main NFSen installation, and you can have that in parallel. What my machine is doing. Okay, so if we look on the above pans, the traffic, it may not be simple to spot anomalies in the lower source of traffic. I mean, in the brown part, or okay, and a thing like Old Winter enables to, just look at the trending and the patterns, the usual patterns, and with that you are able to spot an anomaly which was clearly not visible in the main part. I mean, if you see what I mean. Okay, so with that you may be able to spot, more specifically in less verbose sources of information. Just a concrete example, quickly. So example below, purely fictional, of course, but if you were to, you may want to have a look at traffic with certain characteristics. I mean, for example, some ICMP types and code, or with certain protocols or stuff like that. Actually, the first requirement, we can do nothing for that because there is no IP option which are captured with NetFlow. So we are not able to match traffic based on some options. Anyway, we are able to look at ICMP traffic and other protocols. The last clause is that the packet is sent to physical or virtual address. It's interesting to have a look if you have some kind of traffic on your network. So ICMP case, with ICMP, just by that, the way it works is that to encode ICMP information, indeed, the source code, the source port, is always 0. So when there is ICMP traffic captured, forwarded by a router, it will export a record of that ICMP traffic with a source port of 0. And the code and type are shoehorned into the destination port. Okay, so if we have a look at the record, the little problem that we have with NFDump is that for now there is no specific keywords to do queries on the type and code. So you have to use the actual 16 bits value to do the query. So meaning if you want to match tape 8, and 13 and so on traffic with NF dump, you will end up building a filter like proto ICMP and port blah 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 blah. Take your calc, that's easy, but that's a bit boring to do. Yeah, okay. Adding a new profile and channel, we saw that. Okay, direction. I said that there is no way to build a direction out of the records because the way it's done. And biflows, it would be cool sometimes to work on biflows. By the way, all the commercial tools working with NetFlow end up matching biflow. So meaning that you are able to see with one record both sides of the conversation. And NFDump does not do that. So you can fire your favorite script language of yours, like Perl or Python or Ruby or whatever, and build a small aggregation, biflow aggregator. That's quite, that's not hard. I mean, okay, from pcap to NetFlow, but I said some things about that. Just BGP, just a graph. I'm not sure there is actually an interest in looking at BGP traffic from a NetFlow perspective, but well, BGP is pretty much in every meaning of the term like a heartbeat traffic, I mean, and so this is how it looks like in a regular, with one peer, in a regular update and withdrawal cycle, I mean, so regular exchange of packet. And this is how it looks when there is some eBGP instability, multi-hop instability. So, of course, we see a big increase of traffic. So I mean that only by looking, and if there is a massive or some increase of the updates received, for example, they will end up being in your graph. So with that, I'm not sure, I don't know if this is useful or not. Okay. But I mean, with that at least, you're able to say, okay, at that time, there is a peak, there is an increase of BGP traffic between that and that peers. And what does that mean? So all you have to do, well, it's up to you to fire your BGP logs and have a look in more detail at the application level, I mean. And just, okay, I talked about traffic directed to the void, so for a very, very low volume, very, very low volume sources, but just in gray, you see patterns in the traffic directed to non-routed, nor addressed, non-used addresses, or non-routed, or discard, or diverted, whatever you end up with. And so we can see that in gray. We can see that the patterns during time, yeah, okay, agree. You will read the slides, agree, which is a pretty cool aggregation stuff. And NetFlow. Flow spec is a very cool thing, but okay, I have no more time. Just for 3 links actually, but on the NetFlow site, and there is a cool, the last link is a repository, sorry, of all commercial and open source tools working with NetFlow, basically, quite exhaustive. So, okay, thanks for your attention. Sorry for being long and boring and whatever. And, okay. Yeah. Just last word, but my plan was actually to spend way more time with interactive data, and I suppose to have more time than that. And, okay, sorry for that, but there is a lot to do in the analysis part, obviously. And okay, so thanks.